Hello and welcome to this new edition of the Foojay Podcast. In this episode, we're traveling to the cloud, looking at how to deploy and run Java applications.
Welcome to the Foojay Podcast, all your news about OpenJDK.
Java was born in 1995 when the internet as we know it today didn't exist yet. Cloud servers, Docker, Kubernetes, distributed systems scaling up and down? These things are now part of our daily job, but Java wasn't originally designed for it. Today I want to learn if the recent evolutions in OpenJDK and ongoing related projects will make Java a full cloud member.
Nice to meet you all. Thanks for joining the podcast today. So my name is Jansen. I was actually born after Java was created, which is a bit of a weird, I program with a language that's older than me. It's a weird sort of situation. But I'm a developer advocate at IBM. I live and work in the UK, looking at mostly sort of Java-focused technologies, hence why I'm here. So looking at OpenLiberty, reactive microprofile, KTE, all that great stuff. Before I was a developer advocate, I was a biologist. So I've had a bit of a weird, fun route into tech. And that's me.
My second guest is Mark Heckler.
Okay, so I started with Java in very early days, like pre 1.0. So I was like 2 years old at the time. I'm kidding. So worked with it a long time in various capacities as a developer, engineer, and eventually found my way to advocacy as well. I am currently a principal cloud advocate of Java and JVM languages at Microsoft. A little bit of background, I guess, Oracle, Pivotal, VMware, etc. So, just happy to be here. Thanks for inviting me on. Personally, I wife, kids, dog, and licensed inspirated pilot. So I like to get up in the clouds for real when I'm not working in the clouds right here at my desk.
Hello, everyone. Thanks for having me. So my name is Guillaume Laforge. I'm a developer advocate for Google Cloud. I'm also a Java champion. I'm known as well for the being one of the co-founding members of the Apache Groovy programming language. What else? For the French-speaking audience, maybe they know my participation in the Cast Coder podcast in France and in French. And I've been developing with Java for a while as well. I think I started with Java 1.02 or something like this, at least my first experiments with it. And I've programmed in Java since then, or in Groovy, of course, and a bit of other languages at times. At Google, I've been focusing mainly on serverless products, so I'm always interested in seeing how to best deploy Java applications on functions as a service products like Cloud Functions or apps on App Engine or containers on Cloud Run. So these are my favorite places where to deploy my stuff. And more recently, I've been focusing a bit on generative AI because, we're putting AI everywhere these days. And I'm pretty interested in LongChain4j, for example, which is the long chain for Python equivalent for the Java developers. And I'm happy to talk about this at conferences lately. So, I think that's about me.
And I'm Frank Delporte. I'm a bit older than Java, using it for over 15 years, I think. And recently joined Azul as a technical writer, but also making these podcasts just because Java is the programming language I love the most, and I want to learn a lot about it, or as much as I can. Okay, we have three experts in the room. Do you have any idea? Can you give us some insights about how much Java is running in the cloud? If you're looking at applications, for instance, deployed at Google, Microsoft, have you any idea how much of them is Java?
For Google Cloud, I think that's a good question, but it probably depends on the actual platform itself, in the sense that, for example, on Google App Engine, Java has been there since 2009, I think, or 8. So there's lots of old Java applications on App Engine. For products newer, like Cloud Functions, probably less. And Cloud Run, since you can containerize lots of stuff, lots of languages, it's a big mix of things. But Java has always been, there are really lots and lots of customers who are using Java. Also on GKE, on our Kubernetes platform. And often, as far as I remember, so I didn't check the statistics, and perhaps I wouldn't even be allowed to share them publicly anyway. But I remember that Java is often for big enterprise applications, and we're seeing, even if there are maybe on some platforms less Java applications than maybe other languages, sometimes the Java applications, since they are bigger enterprise apps used with many more customers and users, they are sometimes accounting for more traffic coming from those Java applications, regardless of the actual popularity of the language on the various platforms. So lots of Java, definitely.
And Mark, on Microsoft side, do you think you have a view on that?
I don't have any specifics of it similar to Guillaume. I don't necessarily. I suppose the specific numbers aren't quite as important as just the fact that it's very important to Microsoft and very important for us to serve the Java community. Because if you think pre-cloud, we used to always in the Java community talk about how much of the world ran on Java and how many mission critical, globally deployed applications relied on Java, typically running on enterprise Java in some fashion. And that hasn't changed. So I know that regardless of what the platform is within the platform, whether it's functions or containers or just an app environment or Kubernetes, et cetera, it's Java is very well represented. I'll put it that way. So the recognition within Microsoft is Java is very important. The Java community is very strong, and the Java customer base is both vocal and very very, very strong, I guess you'd say, in terms of representation. So, very, very important market and community, which we've known all along, all of us, right? From all our various different perspectives. It's just nice to have some level of validation within.
Yeah,
and Microsoft
absolutely.
has hired lots of Java luminaries, actually. So
yeah,
there are a lot of big Java experts there.
When I came in, I think I was the 10th Java champion that joined, and I think we've since added 3 or 4 or maybe more now. It's kind of hard to keep up with, but it is a very vibrant community within Microsoft as well. And again, we try to bring that external focus. I know Guillaume and Grace do the same thing. You try to bring that external focus because within large corporations, it's very easy to not necessarily be quite as in touch with the community as you'd like. And we are part of that community. So we serve to act as a pretty good conduit, I think, both directions.
Grace, you as a younger enthusiast, you grew into the language. How are you looking into the evolutions of Java? We talked about this briefly at JFall, but now you have some more time. How are you looking at Java in this cloud environment?
It's been super interesting seeing it evolve, especially from a perspective of not having worked with it since its inception. Because I kind of came into software development at the stage that we were already looking at microservices and deploying to the cloud. So I kind of had to catch up with decades of understanding monolithic applications and applications running on-prem. And it was interesting to understand the challenges that came with that in terms of people trying to move to more cloud-native architectures, cloud-native platforms, but also being able to keep so much of what makes Java a brilliant language. And I think that's why it succeeded for as long as it has. The community, but also the innovation that comes with it. The fact that we're able to have, strong security, we're able to have portability and flexibility across different libraries, different frameworks, runtimes, platforms. I think that's a really great point of sort of strength of Java that has allowed it to be able to continue evolving, to be able to have sort of things like reactive programming. We're looking at things like Project Loom, looking at, different ways of controlling threads, garbage collection, all this stuff is what makes Java special. And I think that's what's allowed it to continue evolving to be able to cater for the cloud. Because without that evolution and without that support from the community, I think it would have potentially died a long time ago. It's one of the oldest languages out there and it's still really going strong. So it's been really nice to jump into a community that's both really established, but equally growing and changing at such a rapid pace that it's a really interesting environment to be in.
Mm-hmm. I think you mentioned a few things which are important. So we have the 6-month release cycle, so we have continuously improvements, new things, but you also mentioned security. And I think a lot of people are not aware of this 3 months release cycle where new security updates are coming in. You think that's equally important for the security part?
Oh, yeah. I mean, I think we only have to look at recent examples of major vulnerabilities and, cybersecurity attacks and things like this to really gain an understanding of just how important this subject is. The rising popularity of subjects like DevSecOps really highlights the fact that security isn't just for security experts anymore. Security really has to be front and center of all elements in development throughout our software development lifecycle. And I think having that regular release cadence of security updates to be able to ensure that Java remains as strong as it is in that regard is really important, especially in what is a chaotic and often dangerous environment of the cloud, because anyone could be trying to access your code. You could be deploying in loads of different environments. So yeah, I think it's critically important. But I don't know if you guys want to add more to that.
Yeah, I totally agree with that. And I think it's part of the trust enterprises have within Java. Because if that wasn't the case, I think Java would probably not be as successful as it's been. I mean, going on, all those years. So yes, this is a strong focus for the JDK, the Java engineers, those teams, and the trust enterprise have. So it's also the evolution, it's also the community, etc. But for enterprises, that's a key, in my opinion. Yeah.
In those new versions which appear every 6 months, do you see many things focusing on that cloud environment that help develop Java applications which are better suited to run in the cloud?
I think so, yeah. So for example, the work around GraalVM is interesting. Or I remember some changes when we had some issues in serverless environments or in JKE with regards to memory, CPU counting and such, and the OOM kill on GKE and all those things. So they also adapted the JDK, the runtimes, to cater to the cloud environment in general. Mm-hmm. So definitely, I think it was part of their. It was certainly top of mind because the cloud is a key place to deploy your applications nowadays.
Grace, you mentioned already DevSecOps, which is one of the many, many ops we have.
Oh, there's so many out there. It's like an endless list nowadays. GitOps, FinOps, MLOps, like the list just keeps getting bigger and bigger.
Mm-hmm. And is the FinOps is the FinOps a problem for a cloud provider? Because the cost of what companies are doing in the cloud is a critical factor nowadays. Isn't that an ongoing battle also for a cloud provider of you still have to earn your money, of course, but you also have to provide the cheapest possible solution that someone can use?
I think there's room for that, though. I was looking at a few stats from things like the State of Java report from Vardin, and some of these sort of like enterprise-wide reports. And there's still over 50% of Java applications that aren't on the cloud. So that's a huge amount of the market that's still going to, at some point, probably move to the cloud in some capacity. So there's a lot of room there in terms of enabling applications to be deployed in a cost-effective manner, while still allowing room for profit or for, obviously they're a business at the end of the day. So they need to be making money somehow to allow for growth in the market in terms of getting those existing applications that aren't on the cloud onto those cloud platforms. So I think there is a balance there. And I think that's potentially where we can enable sort of competition between different cloud providers, but also sort of a low barrier to entry for those applications to move to the cloud.
Mm-hmm.
And if I could, I would posit that that's probably the wrong perspective, or maybe the wrong question even entirely, because I mean, at Microsoft at least, and this may apply universally or maybe less so, I don't know, but we're very focused on getting the customer the best value as much as possible, every time we can, every way we can. And what you find is that if you think back, some of your early programming days, and you found a way to deliver some really cool feature quickly, and it's out the door, your workload didn't go down, because what happened is your customers, your internal customers, whomever, they realized that, wow, Grace can crank this feature out in a couple of weeks. So now, the 6 months that I'd allowed for this, I have extra time. So now all of a sudden, Grace gets 15 more change requests or issues or upgrade requests. So the workload doesn't go down. It's just the opportunities go up. So if I'm at a customer site and my cloud provider is saying, look, we can save you some money on this, the first thing I'm going to do is go, great. Now I've got this backlog of things that now I can look at implementing. So everybody wins in that circumstance. And that's kind of the way we approach it. We try to make, and I again, no commercials because everybody has their kind of own take, but we try to be the destination of choice. And part of that is being the partner and making it as cost effective as possible to deploy X, Y, or Z application. And knowing full well that it's in everyone's best interest to do that, because then the customer has more latitude, has more ability to implement more capabilities that their customers are demanding, and faster, hopefully. So,
Well, I'd like to highlight 2 points. So this is one maybe a bit specific to Google Cloud, but for example, I think that was last year that we introduced this feature. We've got I forget the name of the feature, but basically when you're using the Google Cloud Console, there's even like a pop-up that appears if you're, for example, using a huge VM in Google Cloud Compute Engine to run a small workload, and it will suggest, hey, you should be using a smaller VM because this one costs too much, considering the kind of workload you're running on it. So there are different tweaking configuration suggestions that appear here and there, instead of over making the customers overpay for something they don't actually use. And more globally, so this time not really related to Google Cloud itself, but when we look at all those cloud providers, for example, on the serverless platforms, all those things that scale up and down depending on the traffic. Maybe they run at a regular pace. Maybe that would be more costly than perhaps a VM. But on the contrary, if you've got very irregular traffic, or if your website, your web application is on primetime TV, that it's being mentioned, and suddenly you've got a huge, peak of traffic coming up. Those systems actually scale smoothly, and they can handle the load. And when there's no more traffic, they go back to a lower consumption level. And that's interesting, because instead of over provisioning lots of capacity to handle all possible situations, actually it's going to scale up and down just depending on traffic. That's I think it's good, how to say that in English? Good
profit for what you do.
There's an expression. I forget. Good bang for the buck, or something like this. No.
Yeah.
Yeah. Okay.
Bang for your buck. Yep.
We had, I think, also in the JFL podcast, we were discussing the ecological impact of running things in the cloud. Doesn't matter if it's in the cloud, if it's on premise, you have to pay energy. So energy, it has an ecological impact. But the discussion was a bit that there are no tools available to measure how much energy you're using. We can measure the traffic, we can measure CPU, we can measure memory. Do you have any tools to measure how much energy you're using?
On Google Cloud, for example, when you pick, we've got a pricing calculator. I think it's also able, maybe I'd have to double check, to mention associated CO2 emissions and such. But for example, when you decide to create a new project on Google Cloud, when you have to pick a region, where do you want to run this workload? So let's say I want to run in Finland, then you're going to see 2 or 3 green leaves saying, in terms of CO2 consumption, it's the region which has the best use of the local energy, etc.
Yeah,
So
yeah.
it emits the less carbon, it has a lower carbon footprint. So I think cloud providers try progressively to ensure that customers have the choice and know about what kind of resources they are using and what could be. I don't think, because I think it's complicated to really calculate the exact cost in terms of CO2 emission, because I mean it's also, it depends so much on your actual workload and traffic patterns and everything. It's just estimations that you can make, but more and more I think it's going to be more obvious, like just choosing the right region if you care more about CO2 versus just pure price, etc.
Yeah, I read about an experiment by Microsoft to put one container in the ocean to have cooling from the water. Now, I can imagine that building that container is not that simple. So there is some trade-offs there, I think, to be made. But yeah, I can imagine that there are a lot of experiments in this topic to measure and minimize the ecological impact.
Yeah, and I think to an extent, there's almost a thought, as developers, we're aware that, we need to make our applications as performant, as efficient as possible, because even if, as you were saying, even if we're not able to estimate accurately exactly how much CO2 we're using, we know we're using some. So if we can reduce that by any means possible, then that's always going to be beneficial, even if we can't see the exact numbers right now. So if there's any way that we can reduce, as you were saying, like the VM size that we're using, the CPU we're utilizing, if there's any way in which we can make our applications more memory efficient, more CPU efficient, then all of this is going to be beneficial in terms of reducing our ecological impact. So I think as developers, even if there's a limited set of tools right now, maybe there's an open source project in there somewhere. But even if we're not able to see it exactly, I think we all have a responsibility to try and reduce those numbers, those metrics, to have an impact in some form or capacity when it comes to application development.
It is interesting, though, if you consider it, that most of the things that we strive for as developers kind of align, maybe not perfectly, but very nicely with better ecological, stewardship or use of resources. Because if we want better performance, smaller units of compute, and faster executions, all of those things typically imply that you're demanding fewer resources. The ability to scale out and in dynamically and set up automatic scaling or certain triggers of scale based on demand is far more ecologically friendly than over provisioning. So in many, many, many ways, we have come a long way just by aligning by the goals being aligned. It's not like we planned this, but it does work out very nicely in that regard. Now, as Guillaume and Grace have both mentioned, the better tools we get to measure and monitor that, the better we can do. But it's kind of nice to see at least we're heading in the right direction now, I guess. Progress is good, even if unintentional sometimes.
But it's funny that actually costs and CO2 emissions kind of align,
Right?
That's a good thing because everyone benefits.
So even as a developer, we should also be a bit of a FinOps and look at the financial impact.
Well, and I've mentioned this before because some folks who don't know or know me know that I have an MBA. So I've done a lot of economics work and finance work. And a lot of times I I haven't for some time, but I have given a talk in the past on how to assess projects, assess initiatives, and determine if they make sense financially for your company. Because many times when we espouse a project, when we try to advocate for a project, and I say advocate not in the term of advocacy, but in terms of like we're an engineering team and we see something that needs done, something that's beneficial to our company, our customers, et cetera. When we go and advocate for that, we use engineering terms. And the folks who are signing off on us being able to do that use accounting terms and finance terms. So there's this impedance mismatch right out of the gate. So when we learn their language and learn to critically assess our own projects, we can determine early on, one, if the project doesn't make sense. And if so, we just stop it right there. We don't bring it up. If it does make sense, we learn how to better advocate for it in a language that the people in control can understand better and get behind it as well and be our allies versus our enemies, so to speak. So in many ways, when we look at these things to understand better the finances of it, the FinOps, it makes our lives easier. It makes our projects more successful. And in many ways, also, it allows us to choose better projects and more good projects as well. So again, I kind of look at this and there are many headwinds that we all face in different ways, but there are certain things that kind of work in our favor. And these are things that we probably should be leaning into a lot more than we do.
Yeah, but a little personal story that I was experimenting in a previous job, and I think I burned the budget of 1 month in 2 days by just doing something wrong with the database, which was cost per transaction. So I think indeed, as a developer, knowing where the dashboard can be found with the cost is pretty important of your cloud.
Well, thank goodness this isn't an episode of our biggest mistakes that cost our companies money.
Yeah, I think we've all had that email from someone being like, did you mean to leave that VM running?
You have a few hours of our mistakes. Yeah, but that was also talk at a few conferences of Holy Commons, is indeed that there are a lot of servers running which are doing nothing or almost nothing. Isn't it too easy for developers to start new servers?
It's an interesting question, because when you look at the energy efficiency of everything we run within software engineering, I think I saw a stat somewhere that was something like data centers around the world consume more CO2 than entire countries, like Peru and things like that, smaller sort of countries, but still more than a country is the main point here. So it is insane when you think about just how much energy and how many resources we are consuming. And it does bring to light those questions of, should there be more auditing of some of the sort of servers that we're bringing up? And should there be more of a process there? It's a difficult one.
Mm-hmm. More and more of our economy is going through the cloud in a way or another. So it's kind of natural. So, I mean, if in, decades and decades ago, maybe we would have been able to compare, the infrastructure of electricity or roads to be something like a big share of the budget of all the countries. And today that's those electronic highways that are a big part of the budget of companies and countries. So I think it's quite natural. I'm not saying this to say, hey, let's spend even more, let's waste even more money. But I think that's a quite natural trend going upward as more and more of our lives are digital, basically.
Yeah, and to piggyback on what Guillaume said, and actually Grace too earlier, I mean, we Microsoft, and again, I can only speak for us, but I know this is not a unique necessarily operating principle, but I mean, for instance, I get emails saying, hey, I noticed you have this resource that, is still running. Do you want to, shut this down? Maybe, suggesting ways that you can be more efficient in terms of your resource consumption, your personal resource consumption. And I know this goes to larger accounts as well. But I kind of, again, and this is one of those things that you look at and say, okay, there are probably X amount of resources out there running that don't need to be running at that level or at all, which is wasteful. And we need to work on that. I'm not dismissing that at all. But if you think back before the cloud type of provisioning, what would happen when you needed to field a particular application is you would have to go through layers and layers of bureaucracy and requests and requesting material and the equipment and the space in the server rooms and get it provisioned, hardware provision and the OS and the software stack provision and the tests and all this. It was crazy expensive, and not just in terms of cost, dollar cost or currency cost, but also in terms of the time that it took. So if you had everybody nodding in the right direction that this application was vital and it needed to be done, it may be 6 months to a year before you could deploy the first iteration of it. So the cost comparison of that versus I'm running a VM and I forgot it's running is still orders of magnitude better by far. Again, it's not that we need to ignore that. It's just that I think we're heading in the right direction. So now at least, and of course, it is much easier to audit that than, well, where are we in the progress of deploying application XYZ? I don't know. We're waiting on somebody to approve the equipment. And that's been 3 months. So
the fact that all those applications are running within data centers, from various customers, etc. I hope there's a better utilization of the actual resources. So unlike in those old days where you'd provision servers, maybe at some point, you had those servers, but you didn't really need that much capacity. Well, it was there and lingering around. Whereas hopefully in the cloud, because of factoring everything together, all the customers, all the apps, I hope there's better utilization of CPU, memory, bandwidth, and everything. I hope so.
Mm-hmm. It brings back memories if you talk about you need someone to approve the server and have it installed. And indeed, the speed that you can nowadays build something and have it up and running, available at a web address, within minutes, you can go from a very rough idea to something in the cloud. And that's indeed, it's tempting, but it's also very great. If you go back to Java, what are you looking forward to for the next versions? So there are a lot of JEPs, ongoing enhancements, which will be coming in the Java language sooner or later. Are there specific topics that you're looking forward to use them in the cloud?
On my side, so I mentioned GraalVM earlier. So it's not JEP, of course, but there's GraalVM. There's Project Leiden. I'm not sure if it's pronounced correctly. Also, even things like Loom for concurrency. It's going to be better usage of your CPUs, basically, because of those lightweight threads. I think those projects and features and JEPs will allow to have even better functioning Java applications that start faster, that consume less memory. And for example, I mentioned that I was focusing on the fully managed serverless kind of platforms, and on those platforms where you need to scale up and down, etc., according to the traffic. When you have to scale up, you have to start fast, and often the let's say the plague of serverless platforms has always been cold starts. But with things like GraalVM or Project Leiden, you're going to start much faster and use less memory. So it's better for the CO2 emission. It's better for the response time, the latency of your apps. So I'm very interested in those things that manage to keep your application running and better use the actual underlying systems and memory and CPU and everything.
Mm-hmm. I need to mention Project CRaC also here.
Something. Oh yeah, CRaC. Okay. Yes, I forgot about CRaC. Sorry.
And CRiU, is that how you said CRiU? CRiU?
CRiU, I have been given a talk about this, so I can dive into it. But CRiU is actually the system within Linux being used. CRaC is the API on top of it. But indeed, the speed up of Java applications, it is a discussion point if you compare Java to other languages. But I think also the environment that it runs on is probably a topic. Is it a Docker which needs to start? Is it a native application, as you said, on a VM? So I think there's a lot of options there, and we'll probably see a lot of improvements there in the future.
I mean, we have InstantOn with Liberty. So utilizing that same underlying CRiU. I think that's how you pronounce it. I always say it wrong. I always say CRiU, but sounds more like freezing someone, So I think I'll go with CRiU. We have InstantOn, which is a very similar sort of feature. And I think we're looking at the moment at whether we could utilize CRaC with InstantOn. Looking at checkpoint restore with Liberty, it's super cool. The reduction in, as you say, startup time, the speeds you can get when it comes to development is it's amazing in terms of deploying your app in a way that's more aligned with serverless. I'm not going to say it is serverless speeds, but more aligned, I think, enabling just that more cloud native style of deployment that we're aiming for. So I've been experimenting with that.
And,
And
and
actually, my framework of choice is Micronaut. And Micronaut added support for both GraalVM, of course, but also CRaC. So I've played with GraalVM with Micronaut, but not yet CRaC. So that's next on my list.
I love also how this works. So you have these community projects like CRaC and Liberty, and then you have Project Leiden, which has the same goal, but is still, how should you call it, a research project? It's not yet a JEP. It's not yet scheduled to become part of one of the next OpenJDKs. So at some point, they'll probably come together and find one. But I really like how the community is pushing Java forward to achieve this.
I want to piggyback on that, because that was when I stop and think about this stuff, it's just, you can't help but smile inside, because if you've used Java for any length of time, you realize that the pace of innovation has just gone off the charts. And I mean, Java has always been a great language. We've always added things methodically and sensibly and very thoughtfully. And we're still doing that. That's the crazy thing. But I say crazy because we're doing it thoughtfully, and yet the pace of innovation seems to be picking up. We think of this kind of embarrassment of riches that we have when we're able to talk about 3, 4, or half a dozen different things that we're excited about coming down the pike, and probably none of us have played with all of them yet. And there are 2 or 3 that every one of us is probably going, I haven't gotten to that yet, or I've just kind of started researching that, and I can't wait to dig into that. It's if you'll pardon the expression, it's a great time to be alive, because we have so many things that we can play with and evaluate and hopefully use within different contexts, which takes us back to hey, your brain is still required to determine which one you apply in which case. But yeah, it's really nice to have this kind of selection of tools at our disposal, all of which are pretty nice.
And it's great to be able to, as you say, build on top of them. So, even if we have Project Leiden, we have CRaC, we've got all these different sort of projects with the same goal, it's nice that we have this community style of innovation where one can build on the other, and then they can merge, and then we can build upon that and iterate and improve it. And there's no real sense of strict competition, because it's all such a community environment that everyone works together so collaboratively that we're able to get this rapid innovation that I don't think we'd otherwise be able to achieve. You see it with other projects like OpenTelemetry and MicroProfile, for example, enabling things like telemetry for your applications in the cloud, like being able to utilize a project in something like the CNCF and enable that in another open source specification that can then be used by another group of people. It's just wonderful to see so much collaboration and community spirit enabling that innovation to continue.
Mm-hmm. And then also the frameworks which are built on top of it. You mentioned Micronaut. Quarkus also has support for CRaC, I think. Then Spring 3.2, which is now just released, also has it. Mark, in a previous life, you worked for Pivotal. How do you think that they look at how Spring is now in a competition with all these other frameworks, which are also aiming at being a cloud native developed framework, which starts fast? Do you think that's some kind of competition?
I mean, I can't speak for anyone else, but I will say that generally the approach is I think that most people within the Spring camp, and probably every camp take, is that a bit of good natured competition is good. We all have things we can learn from each other, and as they say, steel sharpens steel. So I mean, Spring has been around for a long time, and Spring Boot even much shorter time, obviously, but it's been around for quite a while too. But I think sometimes we get distracted by when did a project start, and therefore it's new and it's fresh and it's exciting. And I have maintained forever that you should look at the commits and what is the commitment to a particular project, library, whatever. What's the pace of commits? So commitment and commits. In terms of how well is it being maintained, extended, upgraded, how well is it embracing the current, the present and the future. So Spring is kind of out there leading in many ways, and in areas where it's not, again, it's kind of that methodical, thoughtful approach to where we are and where we're headed. But every one of the options that you've mentioned, Quarkus, Micronaut, probably a half a dozen others, have something to add to the conversation, and anybody who's smart is going to listen to all of them, because we can all learn from each other. So the whole cloud native thing, I know that Spring Boot was kind of maybe not the first to coin the term, but certainly leaned into that really heavily because the Pivotal team saw where things were going. And here we are, right? So everything is pretty much in the cloud except for a few things that still have yet to migrate or for whatever reason, are staying on premises, et cetera. But this is where we live now. So.
And also, that makes me think of something, the fact that we've got those frameworks that compete. They're actually also sometimes collaborating on some aspects. For example, I'm thinking about the, what is it called, the GraalVM reachability metadata. So those metadata that help GraalVM more easily make your application run as a native binary. Actually, all those frameworks contributed to the GraalVM reachability metadata. So what the Spring Boot team did, what the Quarkus team, etc., all those teams collaborated together. It's going to help those other communities of competing frameworks. So it's nice to see that we also know how to work, hand in hand together for the benefit of everyone, not just for one framework community. That's cool.
I like that you mentioned it's not about how old or how new something is, because I always ask the question, what is the newest programming or the oldest programming language? Is it JavaScript, Java, Python, or PHP? And then you have, all the youngsters or JavaScript. But actually they're the same age. I think Python is even a bit older than the other three. So it's not about the age, it's how about things are evolving and how they keep up with all the new trends.
And a lot of the time, it's often the older languages or the older frameworks or runtimes, whatever it might be, that actually have more experience running enterprise applications or applications at scale, or if they're keeping up with the innovations and the trends and the latest and greatest in terms of features and compatibility and stuff, then actually they've got a whole wealth of experience that they bring along with them for that sort of backwards compatibility as well, to enable apps to be able to migrate. So sometimes, the new and shiny stuff is really cool to look at and get inspired by, but often it's the stuff that we've been relying on for years and years, like Java, that just keeps going and just keeps innovating and gives us, as Guillaume was saying, that trust that we can rely on it to be able to have our applications as we want them to be.
And actually, if you look at those languages, I think, or I posit that the languages that are still there nowadays are still there because they managed to handle properly this compatibility, this backward compatibility across versions, across all those years. Because if you look at, so speaking of my experience of having created a programming language, when I look at how the Java architects managed to evolve Java, which is language which already contained lots of features, syntactical wise or APIs, and how it's been able to continue innovating in spite of, because sometimes I speak about the combinatorial explosion of features. As you add one new feature, it's going to interact with all the other existing features. So it's like a big table of N features across M features, and how do they work together? So as soon as you add a new feature, it's going to be more complicated. And they managed to do that in such a way that you can still run very old Java libraries on JDK 21, and that's fine. Only minimal backward compatibility issues, but sometimes it's for good reasons, or because something's been deprecated for X number of versions, that now it's time to get rid of that. So honestly, I'm very impressed with what the Java architects did over all those years to make the language so mature and so trustworthy, honestly.
I think we should even dedicate a podcast about the whole evolution and how records and what's all related to it has caused in Java to happen, like the improvement in switch cases and the instance of and everything. It seems that what is now becoming available in 21, 22, they were already working on it in 11 and 12. They already had the idea. That's the point we have to reach. And that's also maybe why some things need 6 previews, or I don't know how many we have for. That's one of the reasons I love Java so much. It's so well thought, it's so well engineered, and how things evolve is maybe for some people not fast enough, but it has a reason. I have one more question. It's not really Java related. It's about how you run things in the cloud and how you trace and debug things. Are there specific tools for Java and in cloud environment, how you fix problems if you have a microservice system? That's something I struggled with in the past. If something happens in service A, but you see the impact in service Z, to make it really worse. How do you find things like that? Are there ways that we as developer can think about that? Is open telemetry related to that topic?
Yeah. Open telemetry, and if you're hopefully if you're listening to this podcast, you're using Java, so you're probably interested in microprofile telemetry. If you've not come across microprofile or some open source project, do go check it out. Used by lots of different vendors, which is the nice thing, that collaboration we were talking about. So microprofile telemetry essentially utilizes the open telemetry framework. And what it allows you to do is have distributed tracing throughout your application. So it allows you to be able to really pinpoint down to potential failure points or bottlenecks and exactly where that happens within a request. So you can trace the path of that request as it goes between different services in your distributed application. So it really allows you to dig down, even if it's an impact on the overall application. It really allows you to dig down and debug, where did that failure occur? Why did it occur? Which service was that in? What request path was that part of? And be able to get into the nitty gritty in that sense to really pinpoint it. Because I think otherwise, without distributed tracing, with just things like metrics or logs, it can be quite difficult to be able to actually pinpoint those issues. So yeah, open telemetry is a fantastic tool. Definitely check it out if you've not before.
I totally agree with that, and all those modern frameworks integrate usually with open telemetry. So instead of just, as you said, logging and trying to figure out, okay, is this log related to this other one? I've seen that in the past, but open telemetry is very great for that, for distributed tracing. So even if you're using different products, like let's say I've got my Java application with Micronaut or whichever framework, but then use Kafka. I can also, have this distributing tracing say, oh yeah, so this request actually went through this, and it went through this Kafka queue, whatever, and came back there using the database. That's really awesome, because without that, it's so difficult it's like finding a needle in a haystack, basically.
Yeah,
so
it's the context.
Yeah.
Like that's what makes it so valuable, is that context of, what was this application a part of? Where was this request going? That provides us with the ability to be able to pinpoint. So yeah, it's a fantastic tool. Definitely check out and try microprofile telemetry if you haven't before. It's really easy to implement, especially if you're using a runtime that enables microprofile.
Yeah. I do want to point out, and I know sometimes, all of us have a lot on our plates. So when we're working on trying to figure out an issue with a system, a distributed system, or even a monolithic system, that it kind of becomes all consuming. And of course, if we spend most of our time in distributed systems, we think, oh my gosh, this is so hard. And it's not that it isn't, but as as somebody who has had to actually find and fix issues within a monolith, I always tell people the problem with a monolith is it seems simple. When there's a problem, you know exactly where it is. It's in the monolith. The problem is you don't know where sometimes within the monolith, and trying to find the issue within a monolith when everything is in many ways much more hidden can be equally or even more challenging. So the distributed systems, they add a new dimension of many more challenges. But as Grace and Guillaume have mentioned, you have traces and spans that you can use to follow any interaction across, over and back through numerous hops. So even though it's a little more a lot more cumbersome, let's be real, you can actually trace that and find where the breakdown occurs. So we have some really great tools at our disposal. And in many ways, once you do isolate where that breakage point is, it's a much smaller thing you have to fix than it is within this giant monolithic application. So everything has its pros and cons, and that in that regard, it's harder to get there. But once you're there, it's easier to solve in many cases.
And maybe another tool in our tool belt these days is test containers, because there's once it's deployed in the cloud and you use OpenTelemetry to see what's going on, but also when as a developer, you're developing on your local machine, instead of testing, with an H2 database or something, no, you can just run PostgreSQL, you can run maybe MongoDB or whatever. You can run that within containers on your machine, and maybe you'll be able to coach certain problems, certain class of errors on your local machine as well. So test containers can run so many, databases and platforms and whatnot. Maybe it's a tool to, if you haven't played with it already, maybe a tool to consider next for you to add in your tool belt.
Mm-hmm.
Yeah, it's a great tool. I played around it with myself. It's really that dev prod parity, right? Or environmental parity, however you look at it, in terms of trying to get that as close as possible. So there aren't, well, it worked on my machine comments anymore, hopefully. Yeah. Hopefully you're able to see it as close to production as possible.
Right.
Yeah.
The closer you get to production, the more you can hopefully reproduce the same issues that you'll see in production, because obviously the best test is production. So the more we can approach that and prior to getting there, the better. But micrometer and micrometer tracing, logging, and building on OpenTelemetry, all those are good things coming from the Spring side of the house. But all of them come down to the same thing, which is you have to be able to get insight into where the problems may occur, have a baseline to compare to, and be able to isolate and fix quickly. So,
isn't production the only good test environment?
Well, it's the best one, right? Best and worst, both simultaneously.
Definitely becomes clear. Maybe short discussion about microservices versus monolith. Am I correct that there is a trend to go back to monoliths? There is a lot of articles.
Maybe,
that's a fact. But
maybe the thing that often when there's a new trend, we go all in on that new trend, but then realize maybe not everything needs to be a microservice. So it's more like finding the right balance between the two. Like the smallest fine-grained microservice maybe didn't deserve to be such a small microservice. Maybe some macro service would make more sense. So it's more finding, I think, the right balance between the two. Monolith can be complicated, microservices can be complicated, and sometimes you have to find the right what should be in a microservice or not. So finding the right balance, basically.
Yeah, I like to say it's a spectrum. There isn't one or the other. I think there's a huge spectrum in between of where people can be. You don't have to be strict monolith. You don't have to be strict tiny, fine-grained microservices. You can be somewhere in the middle, and that's totally fine too. I think people need to reevaluate, as you were saying, not just go with the trends because they look cool and fancy and the big cool organizations are doing it. You're not the same as those organizations most of the time. You'll be a different size, you'll have a different application. So really it's about evaluating what's right for you and finding your place on that spectrum, whether it's microservices or multiple monoliths of some kind. There's a wide array of different architecture styles out there.
Yeah, one of the things that is a wonderful and tragic thing about our field is that when we get a new tool, we just apply it to everything, even stuff it has no business being applied to. There's an old saying, to the man with a hammer, everything looks like a nail. We go around hammering on everything, even stuff that has no business, being hammered on. We make a lot of damage in a lot of cases, and that's bad, right? But the good thing is we very quickly figure out where the valuable applications are, and then where the others that are semi-useful, and then the others that we really should never have gone there in the first place. So we've kind of over-rotated a bit, maybe on microservices, but now we can come back and hopefully not have the pendulum swing all the way the other way, where we re-monolithize, if that's a word, everything, because you have to still employ your brain, right? We still should be objectively looking at requirements and determining best fit based on the options we have at hand, not what's fashionable at the time.
I like that word, fashionable. Like applying that to software engineering is such I'm sat here in my developer hoodie thinking, fashionable, really? But it is.
Hey, all right, yeah.
It's such a fashionable industry, and we don't really necessarily think of it that way in terms of, it might not be a clothing fashion, but following a fashion of microservices, architectural styles, platforms, tools. We get just as excited about those things and want to follow those trends.
So has anybody ever watched like little kids playing football, soccer, whatever you want to call it, depending on which side of the pond you're on? So when they're really little and they start playing, it's just this cluster of kids chasing the ball. And then wherever the ball goes, they're all chasing it. And that's early trends when it comes to new tools, new methodologies, new anything that we get access to. It's only after you use it a while that you start realizing their positions. There's a way to work together as a team that doesn't involve the whole team just chasing a ball. And that takes a little while. And interestingly, I guess the downside is it keeps playing out the same way. But again, the good news is we do learn pretty quickly. So as long as we don't like forget what we learn as we go, then overall, hopefully we're moving in the right direction. But yeah, I always think of the kids, and that's us.
There's even a movie of, I think, 100 kids running after a ball, and they are beaten by 5 good footballers.
Yeah, I've definitely seen that on social media.
They are the experienced ones, and they know what to do. So
okay, now I have to see that. That's great. So if you have a link, please drop that into the chat.
I will try to find it and add it to the show notes, and also include, of course, links to all your work, all your social media accounts. I'm at the end of my list with questions. Is there something you want to be added? Still want to tell about Java, cloud, whatever? It's now your turn.
Maybe just to react to Mark's. When you were saying that we still have to use our brain. But with AI, should we still use our brain? Or will AI do all the work for us?
As long as there are hallucinations, we'd better be using our brain.
I totally agree with you.
But I agree, the LangChain4j, I've seen a demo of it. It's really great. And it's on my list for the next podcast. So maybe I have to invite you back at that time.
Good stuff. Yeah,
definitely good stuff. It's as I've seen it, the demo I've seen, it's really bringing the ChatGPT stuff, and that people are using Python for. It really brings it to Java. So I think it's amazing.
Exactly. It's interesting to see that. So ChatGPT brought large language models in the hands of my daughter doing her homework, etc. But in terms of if you look at for developers, I mean there was. All the machine learning experts develop frameworks, etc. on LangChain, the original LangChain one, in Python. And in order to bring that to the masses of developers, it's great to have LangChain4j and maybe in other programming languages as well. I've seen there are equivalents for Go, for C#, etc. But it brings the power of machine learning in the shape of LLMs into the hands of 10 million Java developers. And there are things that we needed to have maybe not a PhD in machine learning, but be somewhat ML experts and Python developers in order to find or train some models to do some classification or something. Now with proper prompt engineering, proper Java framework like LangChain4j, you're able to deliver 80% of the kind of workloads you would have used a specific machine learning model trained, etc., on GPU before being able to actually do the thing. So it's bringing to the Java developer masses the ability to do really powerful things nowadays.
And it will more applications being written, so more cloud services being used. So that brings us back to the beginning of So that's a good thing for everyone. Okay, that's it for all of you. Then thanks a lot for joining this podcast recording. Thank you also the guests of this episode and you for listening. Keep an eye on Foojay for future articles about development and everything related to the Java world. Thanks.
Give me a Foo, give me a J, give me the friends of OpenJDK.